Good morning. So we're going to do as our first lesson, actually review of what we had done before the break. So this is going to be for all classes, and of course, you guys know who I am. Today is April 6th, so this is going to be lesson 1 of our online learning, but lesson 4 for our probability unit. So again, it's mostly review, but I want to refresh because it's been a while and everybody has at least some homework to turn in to me from this assignment. So starting with independent probability, I'm going to go through and give you some examples. Remember, independent probability is when we have 2 or more events where one does not affect the likelihood of the other event occurring. So common examples of that would be flipping a coin and spinning a spinner. For that matter, flipping a coin and then flipping another coin are also independent events. Going back to the classroom, if I was to draw a stick from my cup, pull out one of your numbers, return that stick, and then draw again, that is also independent because everybody still has equal opportunity to be selected. There's no change in the probability there. And another example of independent probability would be rolling dice. If I roll a die and then I roll it again, the chances of events happening has not changed because the dice itself cannot change. So we have below here one of our rules of independent probability, and that rule tells me that the probability of A and B, remember A and B is the same as my intersection, and that's going to be equal to the probability of A times the probability of B. This is an important rule and one that we should be remembering for any future testing you might experience in other classes or standardized testing that might still be to come. The next definition we have is complementary events. Complementary events is two or more events whose probabilities equal 100%. We mostly stick with 2. Remember that 100% is the same as 1.0. So remembering that the probability of A plus the probability of not A equals 100% or 1, and therefore if I need to find either of those pieces, I would subtract the other piece from the whole. And so this is another rule that we want to keep in mind, that these two things collectively make 1. The next rule we have here is the addition rule. We've worked with this one several times throughout the unit already when calculating the probability of one event or the other. Remember, the or is like the marriage. It's his kids or her kids or their kids together. So the probability of an or is going to be the probability of A plus the probability of B, and we subtract the probability of A and B because this overlap has been counted once in her set and also in his set. We want to remove the duplication. So that's why that subtraction piece. So that's another rule we're working with. And the last vocabulary thing we have here is mutually exclusive. 2 events that have no outcomes in common are considered mutually exclusive because they cannot occur simultaneously. We saw some examples of that earlier when we were looking at 2A frequency tables. So I cannot select a freshman or selecting a sophomore. I can't do those 2 things simultaneously. I can select a freshman or I can select a sophomore, but I can't select one person who meets both criteria. Another example of that would be selecting your favorite color and also selecting your favorite number. That's another thing we cannot do simultaneously. It has to be one or the other. And we're going to talk more about that. The thing about mutually exclusive events is that because they don't have anything in common, I'm going to underline that part, they have no outcomes in common, then when we are trying to find the probability of A or B, we get to remove this part up here with the and because there is no and. And so the probability becomes just the probability of A or B equals the probability of A plus B. Okay. This doesn't negate that rule. They're just going to be used at different times based on the kind of work we're doing.